What if I told you that Tesla has just developed an aircraft capable of making flight delays a thing of the past? A plane that doesn't burn a drop of fuel, barely needs to be serviced. Could lift off straight from your nearest regional airport. No big hub required. It sounds like something out of science fiction, but this time, it's very real. Think about the last time you were stranded in an airport lounge for hours because of unscheduled maintenance. Or when you paid an overpriced ticket only to have your flight canceled anyway. Maybe you live in a smaller city and have to drive to a major airport just to catch a plane because your local airfield doesn't operate any commercial flights anymore. The 2026 Tesla electric plane promises to end that frustration once and for all. This isn't another experimental electric prototype that may never reach production. It's a full-scale reinvention of how aircraft are built, maintained, and operated from the ground up. Tesla's ambition here is bold, but simple: dramatically shorten hangar time, reduce operating expenses per flight hour, make maintenance predictable instead of chaotic, and bring regular air service back to smaller community airports that once thrived. If Tesla succeeds, the results could be extraordinary. On-time schedules might finally become the norm rather than the exception. Ticket prices could actually drop while reliability goes up, and flying could once again be as convenient as driving to your local train station. But the real surprise is that this breakthrough doesn't come from Tesla's battery technology. It comes from how the company reimagines maintenance itself at the center of Tesla's aviation revolution lies a brilliant idea taken straight from its automotive playbook: modular electric propulsion pods. Instead of one massive engine buried deep in the airframe, Tesla's plane uses several compact propulsion modules that are completely self-contained. Each pod includes its own electric motor, inverter, and propeller system, all connected through standardized mounts for power, cooling, and data. If one pod detects a problem, the plane doesn't have to sit in a hangar for days while engineers tear it apart. Instead, a small team of technicians can simply remove the entire faulty unit and replace it with a new one within a single work shift, typically between 4 and 8 hours. After that, they run a quick propeller balance test and a 30-minute ground check, and the aircraft is ready to go. To put that in perspective, conventional turboprop engines often require several days, sometimes a week or more, just to open up for inspection. That's the difference between canceling multiple flights and simply rescheduling one departure. It's later the same afternoon, but Tesla doesn't stop there. The company's design not only makes servicing faster, it makes it predictable. And that's where the real magic begins. Traditional turboprop aircraft demand 4 to 6 hours of maintenance, work for every single hour spent in the air, mostly due to the complexity of their engines with hundreds of moving parts, gearboxes, oil systems, and combustors that constantly need attention. Tesla's all-electric setup eliminates nearly all of that, reducing the workload to just 1 or 2 man-hours per flight hour. That's a 50 to 75% reduction in maintenance effort, since each propulsion module is pre-tested and pre-certified at Tesla's central facilities. Airlines don't need to troubleshoot on-site. They simply swap, test, and fly. This new approach reduces the number of aircraft on-ground incidents by up to half, improving on-time performance by an estimated 5 to 10 percentage points, pushing airlines from 78% punctuality to as high as 88%. For passengers, that means fewer canceled flights, fewer overnight stays in random hotels, and far fewer headaches. But these time savings also translate directly into financial savings, which could make flying more affordable than ever before. Power plant maintenance accounts for roughly a quarter of total operating costs on short-haul routes by slashing both labor hours and downtime. Tesla's new modular design could reduce the cost per seat kilometer by 15 to 25%. On a typical 300-kilometer regional route with around 19 passengers, the operating cost usually hovers around $1,400 per flight. Tesla's super-electric plane could save between $200 and $250 each trip, enough to lower fares while still maintaining profit margins. Those numbers, if scaled across hundreds of routes, could completely reshape the economics of regional air travel and breathe new life into small airports worldwide, of course. Swapping high-voltage electric systems under pressure might sound risky, but Tesla has built precision and safety into every step of the process. Each pod replacement follows a strict checklist. Technicians measure insulation resistance, pressure test the cooling system, balance the propeller dynamically, and run multi-layer electrical checks before the aircraft even leaves the ground. After that, a short 10-minute test, flight verifies that everything works perfectly before passengers are allowed on board. Every action, from pod serial numbers to inverter firmware versions, is automatically logged in Tesla's aircraft database. This digital traceability reduces repeat faults by as much as 30%, by maintaining one spare propulsion pod for every 3 aircraft in service. Airlines can cover 95% of potential faults without major delays. What used to be a week-long maintenance event now takes just a single day, a complete transformation for fleet efficiency and reliability. Yet, Tesla's most clever move might be its minimalist engineering philosophy, the idea that fewer moving parts mean fewer problems. Electric motors are inherently simple. They consist mainly of a rotor, stator, and a few bearings. There are no pistons, valves, turbos, or fuel injectors to fail. Compare that with traditional turbine engines that need constant inspections, oil changes, and overhauls after a few thousand flight hours. Tesla's system eliminates that entire complexity, reducing the number of maintenance hours required by up to 2/3. For travelers, that means fewer technical delay announcements and more planes that actually leave the gate when they're supposed to. Over time, that consistency builds trust, something airlines have been struggling to maintain for decades. Then Tesla took things a step further. The company introduced regenerative braking, a concept perfected in its cars, into aviation. During taxiing and landing, the plane's electric motors switch into generator mode, capturing kinetic energy that would normally be lost as heat and feeding it back into the battery. This not only recovers some energy, but also reduces wear on the brakes and landing gear by up to 30%, extending replacement intervals by nearly 40%. For small regional aircraft that fly dozens of short legs each week, that adds up to thousands of dollars saved every month. Money that can go toward lowering fares or improving service quality. But Tesla's true advantage isn't just mechanical. It's digital. Each propulsion pod is equipped with advanced sensors that constantly monitor vibration, temperature, voltage, current, and pressure. These sensors transmit up to 5 megabytes of real-time data every minute too. Tesla's AI-powered cloud system. This data-driven intelligence allows for predictive maintenance. The system can detect a potential issue before it becomes a problem. For example, if a bearing temperature rises slightly, or if there's a minor imbalance in the motor, the AI automatically flags the pod for replacement during the next scheduled stop. The goal is to prevent failure entirely rather than fix it afterward. It's the same philosophy that made Tesla's cars some of the most reliable electric vehicles on the road, now applied to aviation at a much larger scale. And then comes perhaps the most futuristic feature of all, over-the-air aviation updates. Tesla pioneered this technology in its vehicles, and now it's bringing the same concept to aircraft. Every flight computer, inverter, and battery management system on the plane can receive updates remotely through secure channels. These updates can fix bugs, optimize performance, improve power efficiency, and even fine-tune how the aircraft responds to different climate conditions, all without the plane ever leaving the tarmac for maintenance. This capability can reduce minor shop visits by as much as 90%, saving 2 to 4 hours of downtime each time and thousands of dollars annually per plane. Essentially, Tesla has turned aircraft maintenance into something as simple as updating your smartphone overnight. But while other manufacturers are still struggling with parts shortages, Tesla's secret weapon is already humming quietly inside its gigafactories. The same production network that revolutionized the auto industry by leveraging the gigafactory model. Tesla is creating a standardized ecosystem for aviation parts. Traditional aircraft often have 7,000 to 8,000 unique components just for their power and electrical systems. Each part must be ordered, tracked, and certified individually, which creates massive supply bottlenecks. Tesla's approach simplifies everything by using interchangeable modules built on the same scalable architecture, a level of standardization the aerospace industry has never seen. This standardization means replacement. Parts can be produced in bulk, stored efficiently, and distributed rapidly across global service centers. It's the same manufacturing magic that made Tesla's cars cheaper and faster to build, now adapted for aircraft. The implications are huge. With interchangeable propulsion pods, predictive AI diagnostics, regenerative braking, and OTA software upgrades, Tesla has effectively built an airplane that's designed not just to fly, but to stay flying. Imagine a world